Integrated 2, Chapter 4, Day 5. I think this is the last video for Chapter 4. Then we'll move on to Chapter 5. So what if it looks like this? Again, getting slightly more exotic. You'll notice 24 though. Like we said, the bigger this is, the steeper it is. So this is probably going to be pretty steep, I would imagine. Having said that, what number can I take out of 24, 6, and 9? Hopefully we all recognize that as a 3. So I will get something like this. You can see the benefits of initial factoring. If I put these giant numbers on the diamond, it would be way more complicated, but I'm putting these smaller numbers, so it's going to be much easier. 8 times negative 3 is negative 24. There I have 2. On the side, I will say 8x. And then I'll see, right? 1 and 24 are not 2 from each other. 2 and 12 are not 2 from each other. 3 and 8 are not 2 from each other, but 4 and 6 are. Specifically, it looks like the 6 needs to be positive, right? Negative 4 times 6 is negative 24. Negative 4 plus 6 is 2. So at this point, I will simplify these fractions. It looks like a 4 goes into both of these. So I'm going to get 2x over negative 1. And it looks like a 2 goes into both of these, so I'll get 4x over 3. So I'm left with the equation y equals, don't forget about this 3, 2x minus 1, and 4x plus 3. So what would be my equations? My intercepts. I'll add 1 to both sides. So x is 1/2. So I'll get 1/2, 0 would be this x-intercept. Over here, 4x plus 3 is equal to 0. I'll subtract 3 from both sides. I'll divide 4 into both sides. I'll get x equals negative 3/4, which is obviously negative 3/4, 0. So if I were to graph this equation or this equation, I would expect them to look the same, and I would expect them both to have x-intercepts at 1/2 and negative 3/4. And I would expect it to be pretty steep, right? So let me go ahead and set this up in Desmos and see what it looks like. First, we have a x-intercept at negative 340 and at positive 1/2, 0. And you can see we have a very steep parabola like we discussed. And you can see those two do yield, whether we write it as a sum or whether we write it as a product, we do get the same parabola. Set up the next problem. Kind of fun. It works backwards. What if I started with negative 3, 0, and 5, 0? What if I told you these were the x-intercepts? Can you work backwards in order to get the equation? So I would love it if you would pause the video right now and actually try this. I think you would find it kind of interesting and see if you could do it or not. So I paused. Hopefully you did too and tried that. Let's see what you come up with here. So my thought would be, if I work backwards, I know that my equation needs to be something like this. How do I get a negative 3 out? Well, if this was x plus 3, a negative 3 would turn this into 0. And if this was x minus 5, 5 would turn this into 0, right? So here we go. These would be what I would have here. And now I'm going back to chapter 1 of the book, right? So I turn my solutions into factors. And now I'm going to go and I'm going to use an area model just like we did at the beginning of the year. And I'm going to see if I can rewrite this backwards. So it looks like I'm going to have y equals x squared minus 2x minus 15. So the question is, if I were to graph this equation or this equation, would I get x-intercepts that look like this? So let's see. Here we have the same graph, and you can see that we do have x-intercepts of negative 3, 0, and 5, 0. So we actually were able to start with the x-intercepts and work our way backwards. So whether we're given a problem in standard form, we should be able to factor it down to get our x-intercepts. But if we're given the x-intercepts, this is, I think, the big trick right here, to be able to rewrite it as a the product, and then from there use our area model to put it back. So just kind of fun to work backwards. So let's go and set up our final problem for the day. It's kind of a short video and go from there. If we get a problem like this, I hope you see kind of our error here, or our issue here. Clearly the A is 1, but there is no B. Well, think about it. What is 0 times x. It would just go away. So our b must be 0. And our c is negative 9. And there is some patterns and there is some tricks to recognize something like this. But I think that sometimes patterns are best recognized. If people show you patterns and you don't see them, it can be frustrating. So I'm just going to show you the normal way to do this and see what comes out. So first of all, is there any number I can take out of 1, 0, and negative 9? There's of course not. So I will set up my diamond. A times c is negative 9, b is 0. I'm just going to put that in there like normal. You can see my a is 1, so it's 1x. And now, what do I get on top and bottom? Well, 9 and 0 aren't going to add to 0, but what about 3 and negative 3? 3 times negative 3 is negative 9. 3 minus 3 is 0. Right? Can I simplify this? I cannot. So I get x plus 3 and x minus 3, obviously. I'm going to get x equals negative 3, 0 for this x-intercept. And I'm going to get x equals 3, or 3, 0 for this one. So let's see what happens when we graph these, and let's see if we get these x-intercepts. We did indeed get the same parabola, and you can see that we do have our x-intercepts of plus 3 and negative 3. So in a nutshell, that's pretty much chapter 4. Again, we're really focusing on, if we're given something in standard form, how do we factor it using initial factoring and the diamond. Again, those are two different kinds of factoring so that we can get it in factored form. And then when we have it in factored form, we can get our x-intercepts. We talked a little bit about the A, but we're going to talk more about the A in Chapter 5 and in Chapter 9. Again, Chapter 5, we're going to look more at standard form, what we can get out of standard form, and then Chapter 9, we'll look at graphing form.